Woo! It is time for 6.2 trig functions. We're going to go into the unit circle and we're going to review some special right triangles. There's really two methods, two schools of thought of how we can do these problems. So we're going to show you both, which is always extra exciting. Alrighty, so from 6.1, if we do recall, we've got our terminal side of the angle. It's where the angle of rotation ends, right? We have the initial side, which is our positive x-axis. Coterminal angles, right? Those are angles that have the same terminal side, all right? And when we're trying to determine a coterminal angle, that would be adding or subtracting 360 or 2 pi, pending what units we are in, degrees or radians. All right, a reference angle. The reference angle we talked about is the positive acute angle measured from the x-axis to the terminal side. As an example, right over here, if we have an angle of rotation of 160 degrees, then our reference angle would be, let me get a pen going here, that angle, which is 180 minus 160, which equals 20 degrees. Cool. There's our reference angle. All righty. Now, why are radians often preferred here? So the radians are just the unit circle, okay? Broken down into fractional values. And then basically you just go a little bit quicker, a little bit cleaner with those values. So let's go ahead and I think you're going to like this pattern that you see here on these multiples of 90, 45, 30, and 60, okay? So first off, with 90, we start out at 0. And let me get a slightly thinner pen. So we'll start out with 0. And then up, and I know that all the way around we said was 2 pi, right? Well, half of that is going to just be pi, right? And half of that is going to be our 90, so that's going to be pi divided by 2. And then if we start counting by pi over 2, 1 pi over 2, 2 pi over 2, which is your pi, 3 pi over 2 is our 270. And again, this is review for many, but I think the pattern recognition is important. Okay, so there's our multiples of 90, right? Does that sound good, Jenny? She's napping in class. All right, we'll keep moving without Jenny. Let's go to the 45s. So for 45s, again, I'm going to start out at 0. Now, if we do recall, this was pi over 2. And what's half of pi over 2? That'd be pi over 4. So what we can really do is just count by pi over 4s now. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is just pi, 5 pi over 4, 6 pi over 4, which is our 3 pi over 2, and then we got 7 pi over 4, and then 8 pi over 4, which is just 2 pi. Cool. Now, one thing that is really great about radians is if you notice, each one of these would be a 45-degree reference angle, right? So, on our 45, our 135, our 225, and our 315, those would all be 45-degree reference angles. Well, what do you see in common with all these? They all have a denominator of 4. So now when you see pi over 4 or 3 pi over 4 or 5 pi over 4 or 7 pi over 4, you know you're dealing with that 45-degree reference angle, and you can figure these out a little bit quicker. Awesome. Fantastic. Let's move to the next one. So now our multiples of 30. So once again, I'm going to pop back up to the 90, which was pi over 2. I don't know why I went slashy this time. Pi over 2. And we have 0 right here. Now, if I divide this by 3, the pi over 2 by 3, I'm going to get 30 degrees because 90 divided by 3 is 30, right? And if I divide that by 3, I'm going to get pi over 6. Awesome. And now, if I go by pi over 6's, I get 1 pi over 6, 2 pi over 6, which is, so your 2 pi over 6, which is pi over 3 if we reduce it. Okay, so we're going to be using that. Then I have 3 pi over 6, which is pi over 2, right? 4 pi over 6, which is 2 pi over 3. 5 pi over 6. 6 pi over 6, which is just pi. Then we have 7 pi over 6. Then we have 8 pi over 6, which would be 4 pi divided by 3. And then we have, where am I at? 9 pi, which is going to be the 3 pi over 2 again, right, as it reduces. That was a weird 2. So 9, now 10 pi over 6, so that'd be 5 pi over 3 when we reduce it. Am I boring you over there, Jenny? She just snored a bit. It was like I was boring her with these wonderful patterns. All right, so from 10 pi over 6 to 11 pi over 6. And then 12 pi over 6, which is 2 pi. So if we're going by 30s, we're going to be going by pi's over 6s. Now, if you look at all of my angles with a 30-degree reference, they're all pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. They're all over 6 for my 30-degree reference. Wouldn't it just be nice if they were over 3, because 30? But nope, that's not how it works. Okay, so all of them over 6 are going to be 30-degree reference angles when fully reduced. Let's keep it going. Now to multiples of 60. Well, we actually already did these. Over here, we've got pi over 3. So we started at 0. Then we have pi divided by 3, right? And then I have 2 pi over 3. Then I have 3 pi over 3, which is just pi. Then 4 pi over 3. Then 5 pi over 3. And then 6 pi over 3, which is just my 2 pi. All right. Well, hopefully that helped you guys see how the radians work, get that pattern going, because it's always good to have some pattern recognition in these situations. And that helps make things a bit easier. And I think a lot of us are drawn to patterns with numbers. And now we got our trig ratios, our Sohcahtoa, the wonderful, wonderful Sohcahtoa. Again, we should already know these, but there they are if you want to jot them down. And we have our reciprocal functions as well. All right, so if acronyms are your thing, all right, we've got our Sohcahtoa and a personal favorite of mine. We have our reciprocals, Sohcahtoa, Sohcahtoa, boom, Sohcahtoa, Sohcahtoa. Can't forget it. Can't forget it if you're saying crazy things like that, right? Anywho. There we go. We've got our cosecant is, again, our reciprocal of sine. Secant is our reciprocal of cosine. And then cotangent is our reciprocal of tangent. And since tangent is sine over cosine, cotangent would be cosine over sine. Lovely. Let's move into the unit circle. All right. So as you can see there, we have that little red right triangle. Now we have our x-coordinate and our y-coordinate. Our cosine is our x-coordinate, and the sine is our y-coordinate. Beautiful. Wonderful. So sine is our y, cosine is our x. Tangent, which we will often refer to also as slope. You may have heard that before. Tangent is slope. Rise over run, the y-coordinate over the x-coordinate. Awesome. All right. And then that will also then apply to our reciprocals. So cosecant is going to be then 1 over y. Y cannot equal 0. Secant will be 1 over x. X cannot equal 0. And the same also goes, I should have mentioned, in tangent and cotangent. We can't have x equaling 0, like cosine cannot equal 0 here. Otherwise, it'll be undefined. And over here, y cannot equal 0, or it will be undefined as well. Okay, and this all applies to the unit circle in red there. Lovely. Okay, now we got our quadrantals. That's kind of tricky to say. So we're going to evaluate those. Well, we have all of our ordered pairs there. 1, 0, 0, 1, so on and so forth, right? Okay, so that would be, again, my cosine of theta, sine of theta. And if it helps right now, I'm going to jot down, we've got our pi over 2. Let's see, where do I want to write that? We'll do it here. Pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, so we want to evaluate the following quadrantal angles. So I have sine of 180. Well, sine again is my y-coordinate, so that would be 0. Okay, cosine of negative 90. Well, if I go negative 90, that means that I'm going rotating down first. So I'm actually at that 270 there. And cosine is going to be my x-coordinate, so that would be 0. Now, tangent of pi over 2. So that's up at the top there, right? And since we said that tangent is y over x, I would take 1 divided by 0. So that would mean undefined. Okay. Now, secant of 3 pi. Well, 3 pi would rotate around not only once, but then another half. So I'd be sitting over here for secant. So now let's use that to figure out what it would be. Well, secant is the reciprocal of cosine. So if cosine is -1, right? If cosine is -1 at that spot, then the reciprocal of -1 is still just -1. You can think of it as like -1 over 1. You flip it, it's still -1, okay? Reciprocal, we flip it. Opposite is where you change the sign, okay? Lovely. Fantastic. So now let's start tackling the other angles here. Now that we moved on from those, from the quadrantals. So we're going to use the special right triangle approach first, okay? Now we have to remember those special right triangles. So with our special right triangles, if you remember from honors geometry, I sure hope you do, across from the 45 is a 1 and a 1, and then if you were to do Pythagorean theorem with that, you'd get root 2. And for my 30, 60, 90, I would have 1 right here, root 3, and 2. Did you notice I changed locations? Pretty crazy, huh? I went mobile. All right. Anywho, next one. Let's see here. We're going to evaluate now. We're going to do this using these 30, 60, 90s and positioning them on the XY coordinate plane. Okay. So if I have sine of 225, well, if I draw this up, I know that would land it in the third quadrant. And I know I'd have a 45 reference for 225, right? This rotation would be 225. Goes past 180. And I know that's going to be a 45 reference. Well, across from there is 1, -1, excuse me. Another -1 for this side. And then that is always positive. My hypotenuse is always positive. So if we're talking sine here, we're talking opposite over hypotenuse. So -1 divided by root 2. Got to rationalize that. And as you are moving with these, once you get back into the swing of things, you'll probably be just rationalizing on the fly. And we're going to get -root 2 divided by 2. Cool. You know what? I'm going to move that right down to here. Awesome. All right, so that's the first one. Now, how about with -240? Well, -240 is going to go up into the second quadrant. I'll change colors here so we don't get them mixed up. So if I draw this in the second quadrant, so if I go 240, -240, that's -180, so I'm going 60 past. So this is a 60 reference. Across from my 60 is my root 3. That's positive because it's going up. Hypotenuse is always positive. And then this side is going to be -1. Okay. So let's see here. Cosine, adjacent over hypotenuse. That's going to be -1 over 2. Nice. No rationalizing with that one. Worked out wonderfully. You don't have to put all of the sides like I just did. You could just do the 2 that you're using. It's really up to you. I always just throw them all in there. Just out of habit, I feel like. Next one. Go with the lighter blue. So if I have 5 pi over 6. Okay, well, I know over 6, that's a 30-degree reference. And that is going to be in quadrant 2 as well. Boom. So if I draw my triangle, I know it's a 30-degree reference because of the over 6, right? That makes this, I'll just throw 30 there. It makes this 1, this root 3, but it's negative because it's going to the left, and 2. Now, cotangent, if tangent is y over x, we're doing x over y. So my x coordinate is -root 3 over my y coordinate of 1, which is just then -root 3. Cool. All righty. And cosecant of 5 pi over 3. Well, 5 pi over 3, that's almost 6 pi over 3, which is a full rotation, right? So we're looking at I'll change colors once again. We'll go with red. I'm going to be in my fourth quadrant on this one. And since it's over 3, I know that it is a 60-degree reference. And that would mean then across from here is my -root 3 because it's going down, right? Yelling timber. Over here across from the 30 is my 1, and then I've got a 2 right here. That 2 is always positive even when it's angled down. Hypotenuse is always positive. Think about Pythagorean theorem. If I do Pythagorean theorem, even if both numbers are negative or one of them is negative, squaring it makes it positive, right? Always good to justify those things in the cabeza. All right, so cosecant, which is the reciprocal of sine. So instead of opposite over hypotenuse, we have hypotenuse over opposite. Let me move it up here because my face is getting in the way. 2 divided by negative root 3. If I rationalize this by multiplying by root 3 divided by root 3, I get 2 root 3 divided by 3. That is all negative. Done. You know, you can even position these triangles in your brain. That's a little harder for you to learn it by if I'm just doing it in my brain right now and not writing it down. So that's why I wrote it down. But over time, you might just be like, okay, let me position this triangle in my head and rotate it around. In all honesty, that's my preferred method. And then again, I do teach geometry as well, so I'm always doing these special right triangles in that class, and that's just a visual approach. It's the type of person that I am, but we will also show you the unit circle method as well. One thing to keep in mind when we're going through these is you have what quadrants the particular functions are positive or negative in. So here we have all of our trig functions are positive, okay? Here, only sine is positive. Here, only tangent is positive. And here, only cosine is positive. So it implies that the other ones are negative, right? Now, if sine is positive, so is cosecant. If tangent's positive, so is cotangent. If cosine's positive, so is secant, right? If I flip it, do the reciprocal, it still maintains its sign. So that's what the ASTC is. All students take calculus as a way to remember that. You could take stats if you want, but that doesn't make sense in the acronym, right? So ASTC, so you could actually just get, like, if you know, for example, in, let's say in this one right here, 5 pi over 6, okay? Well, I know that's a 30-degree reference, so I can evaluate it as such, root 3 for cotangent, but it's in the second quadrant, so I know that it's negative root 3, okay? Cool. Same with cosine of negative 240. I knew that was a 60-degree reference, so I know that it's going to be 1 over 2, but since it's in that second quadrant, only sine is positive, it needs to be negative 1/2. So you can break it down into 2 pieces if you so choose. That's often even more helpful in the unit circle approach, which we are getting to now. All right, first thing we're going to do is, once again, fill out these special right triangles. And here's the thing. If we want to put it on the unit circle, our hypotenuse is, in fact, the radius. Okay? That's going to be our radius of the circle. Well, if this is the unit circle, we need to get that radius to be 1. Well, how do I get root 2 to be 1? Mathematically, I would divide by the square root of 2, which now would make this right here a 1. This would be 1 divided by root 2, which is rationalized would be root 2 over 2. Same with this side. And then for the other one, I would divide everything by 2. So I'd get 1 for this. So if I divide by 2, I get 1 for that. I get 1/2. And then I get root 3 divided by 2. No rationalizing on that one, which is nice. Okay, so we can use these to get our x and y coordinates. Awesome. All right. Well, for the 30-degree, my x value would be root 3 over 2. So let me fill that in. And then my y value would be 1/2. At pi over 4 or 45 reference, we have root 2 divided by 2 and root 2 divided by 2. And then in the last one, that would be where it's across from the 60 first. So if I reorient this, I'm seeing this side now, this side as my x coordinate, 1/2. Right? Because this would be, if I looked at it, this is a triangle. This would be my 1/2 across from the 30. This would be my root 3 divided by 2 across from the 60. Awesome. Awesome sauce. So then this is root 3. It's a weird square root. Even weirder. There we go. All right. Awesome. Fantastic. Wonderful. Dope. So really, we only need this first quadrant of our unit circle to evaluate everything in conjunction with all students take calculus, and here's how we'll do it. So we'll use that unit circle for now. It's best to also memorize that so you can go through things really quickly. But again, special right triangle or this approach works. And each one has its own advantages, really. So sine of 45. Well, sine of 45, that's, again, sine is my which coordinate? Which coordinate? Sine is your y coordinate. Cosine is your x, right? So root 2 over 2, it's in the first quadrant, is what it is. Cosine of negative 210. That's a 30-degree reference angle. Where is it located, though? We'll think about that in a sec. So if it's a 30-degree reference, what's my cosine when it's a 30-degree reference? It is root 3 divided by 2, right? Cosine, comma, sine. You may want to even write that down with this again. Cosine of theta, comma, sine of theta. All right. So it's root 3 over 2, but what quadrant is that in? That's, if you rotate, that puts you in, because you have to go negative rotation, that puts you in this quadrant right here, your second quadrant, right? Well, only sine is positive there, which would then mean that everything else, except for sine's reciprocal, would be negative. So cosine's going to be negative there. Now, tangent is 7 pi over 6. Well, pi over 6, we're looking at our 30-degree reference, right? Our pi over 6 right here. Now, tangent gets a little bit tricky with the unit circle, in my opinion, because what you're going to have is it's y over x, right? So I'm going to take the 1/2, and I'm going to divide it by the x, the root 3 divided by 2. I personally don't like to write it like that as a complex fraction. What I'm going to do instead is, if we're dividing by a fraction, we can multiply by its reciprocal. So let's just do that right off the bat. So my reciprocal of root 3 over 2 is going to be 2 divided by root 3. So these 2's would cancel, and I'd be left with 1 over root 3, and that would rationalize to root 3 divided by 3. Now I got to address the other part, positive or negative. Well, 7 pi over 6 is just past 180, so that's or just past pi, right? I kind of end up sometimes going back and forth in my head thinking about the units. So that's just past pi, which is a half rotation, so that puts me in the third quadrant, which tangent is positive, as noted by our ASTC. All right, tangent is positive right here in the third quadrant. Okay, now the last one, maybe I'll zoom out a little bit since we're running short on room. Cosecant of 2 pi over 3. Well, over 3, that's our value right up here. Now, cosecant is the reciprocal of sine, which would mean that I would do the reciprocal of root 3 over 2, which is going to be 2 divided by root 3. Now, I do need to rationalize this. So if I do that, I get 2 root 3 divided by 3. And then the last piece of the puzzle is, where is 2 pi over 3? That is in my second quadrant. Sine is positive, so this will remain positive. Oh, that's some good stuff right there. So we do it in pieces with the unit circle so that we can just remember less. All right, I only need to remember my first quadrant and what's positive where, okay, to evaluate these. Rather than memorizing the entire unit circle, I can do it in like 2 chunks like that. Get the numerical value or the ratio, and then positive or negative. Now, what if we got them multiplied together? Cosine of 45 and sine of 270 multiplied together. Perhaps maybe some parentheses may have made that a little more obvious. Well, let's just evaluate them individually. Okay. Now, if you want to go the unit circle or the special right triangle approach, whatever you want to do is fine. Cosine of 45 is going to be root 2 divided by 2. Now, at 270, sine is my y coordinate. And at 270, we're down at that bottom quadrantal, which would be a -1 for the y coordinate. So multiply by -1. So now I get negative root 2 divided by 2. Wonderful. All right. Now, this is cosecant of pi over 4 squared multiplied by the secant of pi. So let's, again, deal with them individually. Well, cosecant of pi over 4, that's going to be our reciprocal of sine. Okay. Now, if you want to go about it with drawing a triangle, we could do that. So pi over 4 is right here. That's a 45, 45, 90 triangle. And sine would be opposite over hypotenuse. So this would be hypotenuse over opposite. So I would have root 2 over 1 squared times, and then secant of pi. Well, that's a quadrantal, and it would be my reciprocal of cosine. Now, at 180, that's right over here, we have -1, comma, 0. And cosine is my x-coordinate, so what's the reciprocal of -1? That would still just be -1. And root 2 squared is going to be 2 times -1, which is -2 for my final answer. Now, there's something that I want to point out here when evaluating whether you choose the unit circle or you choose to go triangles. The reason why I chose triangles on the reciprocal is because if I had to do the reciprocal of, if I did sine from the unit circle, which would be root 2 divided by 2, now I do the reciprocal of that, which would be 2 divided by root 2. And now I need to rationalize that by multiplying by root 2 over root 2, which gives me 2 root 2 divided by 2. Simplify, and I'm down to just root 2. That's a lot of work. Okay, it's a lot of just different simplifying and rationalizing. Whereas here, I drew my triangle up and I just did hypotenuse over opposite. Okay? Again, your choice. You might start getting pretty quick with choosing which way would be fastest. But if you are just like, hey, I got to do it one way, that's the type of person I am, then pick your way that you like to do it best and go with it. But I see advantages to both pending the situation, especially when we deal with tangent and cotangent, right? When you're doing y over x or x over y, and now you're dealing with all multiplying by the reciprocal and stuff, or even the reciprocal functions. I often like to gravitate towards the special right triangle approach. Your call, though. Everybody has their own preference. All right, last thing here, guys. If you so prefer, you want the full unit circle, this monstrosity of math, feel free to screenshot this. What I would also add in is cosine of theta, comma, sine of theta for my x, comma, y. Other than that, I think this thing is all good to go. Gucci, as they say. It's got our angles. It's got our radians. It's got it all. It's got it all. And nice color coded too, don't you think? It's so lovely. The different colors for the different reference angles. So if you'd like it, take a screenshot. If you want to just go with the one quadrant, if you want to go special right triangles, your call. Alrighty. You guys have a wonderful day. Thank you for joining in here. America, freedom, rock and roll, Costco, Riverdog Jenny on the gram. If you don't already follow, have a wonderful, wonderful day.